In this section, we are going to talk about complex numbers. So let us consider two real numbers, A and B. Now what we're going to do, we're going to convert B into an imaginary number. So how do we do that? We know that B is a real number, then how do we convert a real number to an imaginary number? It's very simple. We have to multiply the number B with iota. Then I times B becomes an imaginary number. It goes for any numbers, any real numbers which when multiplied by I converts it into an imaginary number. Now we know that A is a real number, B was a real number, but since it is being multiplied by iota, it is now converted into an imaginary number. Now if we take the sum of the real number A and the imaginary number, which is I times B, then this number, the number that we have found out, is known as a complex number. So a complex number consists of two parts. The first part will be the real part, and the second part, which is I times B, is going to be the imaginary part. So let us denote this complex number by Z. Then we have Z is equals to A plus IB. Now this is known as the standard form of a complex number. So in the standard form, we write the real part first, that will be the first term, and followed by the imaginary part. So if we have a number, for example, Z is equals to A, okay, let's take a number 2 plus I3, or you can write 3i, means the same thing. Then this is in the standard form. If we have another complex number, Z1 is equals to 5. Now 5 is a real number. Now what we can do, we can rewrite 5 as 5 plus I times 0. So that means I times 0 means what? It's simply 0. So that means we have the imaginary part equals to 0. So a real number 5 can be written in the standard form. Let's take another example. So if we have Z2 is equals to half of I, so this is only an imaginary number, so it's only consists of an imaginary part. What we can do, we can convert it into a complex number by simply adding 0. Now 0 is not going to affect the value in any way, 0 being an identity, it's an additive identity. So we can rewrite half of I as 0 plus half of I, and here the real part is simply equals to 0. Now how do we write mathematically the real and the imaginary parts? So given a complex number A plus IB, then we can say that the real part of Z is going to be equals to A, and the imaginary part of the complex number Z is equals to be B, so is going to be equals to IB. The imaginary part is going to be equals to B. So here I'm not writing as I times B. I'm considering only the absolute value, so that is the number which is in the real number B. So that will be the imaginary part. For example, if we are given a complex number as root 2 minus 3i, then we'll say that the real part of the complex number Z is equals to root 2, while the imaginary part of Z is going to be equals to negative 3. So if we are given only this part of the information, that the real part of Z is root 2 and the imaginary part of Z is negative 3, then we can say that Z is equals to the real part of Z plus I times the imaginary part of Z. So which will give us the complex number root 2 plus I times negative 3. So it's in the standard form. We can have purely real numbers. So purely real numbers would mean when the real part of z exists while the imaginary part of the complex number z is equals to 0. So that means if we have z is equals to a plus ib, that would mean that if real part of z is a and imaginary part of z, which is equals to b, if its value is equals to 0, then we'll have z is equals to a plus I times 0, will simply give us a, which is a real number. So that means we can say that our complex number z is now purely real. Similarly, we can have a purely imaginary number. So when we're saying that it's a purely imaginary, then we say that the real part of z is equals to 0. There is no real part present. Well, there will be an imaginary part of z which is equals to simply b. So that means when we have z equals to a plus ib, then we know that the real part of z, which is a, the value is going to be equals to 0. We have 0 plus I times b, which is simply I times b, and this is an imaginary number, I times b. So we say that our complex number z is now purely imaginary number. So having said that, we can say that a real number can be written as in the form of a complex number. So we can say that all real numbers are also complex numbers. So we can say that every real number can be expressed as a complex number. So we can say that a real number, this is a representation for the set of real numbers, is a subset of the set of complex number c. We can say in set notation form, we can say this where c is a set containing the elements z is equals to a plus ib, such that a and b belongs to the set of real number r. Now let us talk about how to add complex numbers. So let's say we have one complex number z1 given by a plus ib. This is in the standard form. And we have another complex number z2 which is given by c plus I times d. Now addition means we add z1 to z2 and then we replace the value of z1, which will be a plus ib, and then we add it to z2, which is c plus id. Now addition involves we will be adding the like terms. So the real part of a plus ib is a. This will be added to the real part of z2, which is c. Let's combine it, and then we'll be adding the imaginary part of z1, which is ib, to the imaginary part of z2, which is id. And finally we will write it in the standard form. We have a plus c plus I times b plus d. I being simply a number, we are factoring it out, and we have b plus d. So if we represent a plus c by, let's say, x, and b plus d by y, we'll write it down where a plus c is given by x and b plus d is given by y. So that is the addition. That is how we add two complex numbers. The real part will get added to the real part and the imaginary part will get added to the imaginary part. Let's do an example. So let's say we have z1 is equals to -2 plus 5i, and let z2 be equals to 5 minus 8i. We're going to add z1 to z2. So let's simply write down the values. We have -2 plus 5 of I added to z2, which is 5 minus 8i. We're going to add the like terms, that is the real part of both the two complex numbers. So -2 will get added to 5. We take I as the common factor and then add the imaginary parts. So -2 added to 5 gives us +3 plus I times 5 added to -8 gives us a -3. So this is in the standard form. I could have written it as 3 minus I times 3, but then again we have to write in the standard form. So in the standard form we have a plus sign between the real part and the imaginary part. So that is why I have written the -3, which is the imaginary part of z1 plus z2 within parentheses. Now let's talk about some properties of addition. These are very simple arithmetic properties. So let's talk about properties of complex addition. So property number 1 states that a complex addition is commutative. That addition is commutative. What does that mean? So that means given two complex numbers z1 and z2, when we add them, z1 plus z2 is always going to be equals to z2 plus z1. So that means the order doesn't matter. So whether we begin with z1 and then add z2 to it is equivalent to saying that we begin with z2 and then add z1 to it. So let us try to prove it. So let us consider z1 to be equals to a1 plus I times b1 and z2 to be equals to a2 plus I times b2. Let us first add z1 to z2, and that should be equals to a1 plus I times b1 plus a2 plus I times b2. So that will be equals to a1 plus a2, so we are adding the real parts together, plus I times b1 plus b2. Now what we have, a1 plus a2, this is just the addition of two real numbers, and we know that addition of real numbers is commutative by itself. So we can flip the two values, so we can write a2 plus a1, that would mean the same thing, plus I times b2 plus b1. Now we are going to separate this value, so we are going to rewrite it as a2 plus I times b2 plus a1 plus I times b1, and a2 plus I times b2 is simply z2 plus z1. So that means that given two complex numbers, when we add them, they are going to be commutative. Let's go to the next one, where addition is associative. Addition of two complex number is associative in nature. So associativity means that if we have three numbers a, b and c, What we can do, we can add b and c first, and the answer that we obtain, we add it to a. This is equivalent to saying that instead we add a and b first, and then add the answer to c. So that is the meaning of associativity. Let us apply that to our complex number addition. So we will consider complex numbers z1, z2 and z3 such that z1 has the value a1 plus I times b1, z2 will be equals to a2 plus I times b2, and z3 is equals to a3 plus I times b3. So let us begin from the left hand side. So we consider, so that means z1 plus z2 plus z3 must be equals to z1 plus z2 plus z3. That is also equals to z1 plus z3 plus z2. That is very evident, but we are going to work out with the first two sections only. So we have z1 plus, so z1, so this portion will give us a1 plus I times b1 plus we have a2 plus I times b2 is added to a3 plus I times b3. So we have a1 plus I times b1. Now we open up the parentheses. We have a2 plus I times b2 plus a3 plus I times b3. Now what we can do, we can shift the parentheses, so we consider the first two instead. We have a1 plus I times b1. This is very simple. We have a2 plus I times b2 plus remaining a3 plus I times b3. Now this portion is z1 plus z2 added to a3 plus ib3, which is simply z3. So we can say that addition of complex number is associative in nature. Then the property number 3 talks about the existence of an additive identity. So let's talk about a little bit about real numbers. If we have a real number a, then the additive identity for a will be 0. So that means when we add 0 to a, that gives us the real number a itself. It doesn't change the value of the real number. Similarly, we have a complex number 0 whose real part is 0 and its imaginary part is 0. And when we add this to the complex number z, a plus ib, then we get z plus 0 is equals to a plus ib added to 0 plus ib. Then we combine the like terms. We have a plus 0 plus I times b plus 0. So we know that a plus 0 is going to be equals to a plus I times b plus 0, which is going to be b. So that is giving us back the original complex number z. So that means 0 equals to 0 plus I0 is an additive identity. Similarly, we can say that when z is added to 0, we get back the original complex number z. Let's go to the fourth property, which is about the existence of an additive inverse. additive inverse. So let's talk about real numbers first. So we have a real number a. So there exists a number. There exists a certain number which when added to it gives us 0. What is this number? So we subtract a from both sides, so that gives us 0 minus a. So 0 minus a is simply 0 added to negative a. So we know that previously we talked about it, that 0 added to any number gives back the number itself. So that number is actually negative a. So we know that now that negative a is the additive inverse of our real number a. Similarly, we will have a certain number which is going to be an additive inverse of a given complex number. So let us consider a complex number z is equals to a plus ib. Then there must exist a complex number such that which when added it to z gives us 0. Meaning, so we have z, we need to find out a complex number such that which when added to z gives us 0. 0 meaning 0 plus I times 0. So let's try to find it out. So we have to find out this unknown number. So we're going to subtract z from both sides, so that leaves us with 0 plus I times 0 minus of z. So that is 0 plus I times 0 minus our complex number z is a plus I b. So we have 0 plus I0 minus of a, minus times plus is minus, as minus I times b. Now we're going to combine the real parts. So we have 0 minus a plus I times 0 minus b. So 0 minus a can be rewritten as 0 plus minus a plus I times 0 plus minus of b. Now we know that 0 is an additive identity, so that gives us negative a plus I times negative b. So this is our complex number, negative a plus I times negative b, and this is going to be the additive inverse of a plus ib. So let's check it out. So let's call it z1. We're going to add z to z1. So we have a plus ib, and we are going to add it to negative a plus I times negative b. So that gives us a plus negative a plus I times b plus negative b. And so we have a plus added to negative a is 0 plus I times b added to negative b will be 0. So that means indeed z1 is the additive inverse of the given complex number z a equals to ib. Now let's talk about subtraction. This is very much similar to addition. So what I mean by that is, if I have two complex numbers z1 and z2, then subtraction means z1 minus z2, where we are subtracting the complex number z2 from z1. That is saying z1 is added to the additive inverse of z2. So it's very simple. Let's check it out. Assuming that z1 is a1 plus I times b1 plus z2, which is the additive inverse of z2. So that gives us negative a1 plus I times negative b2. Now let's add the like terms. So we have a1, my mistake, this is a2. a1 is added to negative a2 plus, taking I as the common factor, we have b1 added to negative b2, which is simply equals to a1 minus a2 plus I times b1 minus b2. Let's pick up an example. Let us consider that the value of z1 is equals to 5 plus 8i and z2 is equals to 6 plus 3i. What we're going to do, we're going to find out the value of, let's say, z2 minus z1. So that will be equals to 6 plus 3i minus 5 plus 8i, which is equals to 6 plus 3i minus 5 minus 8i, and that is equals to 6 minus 5 plus I times 3 minus 8, and that gives us 6 minus 5 is 1 plus I times 3 minus 8 will give us negative 5. So this is the complex number in the standard form, which is the subtraction of z1 from z2.